Good morning, students. So, in our last class from the exercise 8.2, chapter quadrilateral, we complete 5 questions, isn't it? So, I hope all of you understood these 5 questions first. Now, here another 2 questions remain. So, today we discuss the question number 6. So, as you see, the question is given here. The question is given like in this way, so that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. So that means here lots of terms represent. First of all, quadrilateral, that means 4 sides are there, bisect each other, that means equally separate into 2 parts, then midpoints. In each side we get one and we have to put one midpoint, isn't it? And when we join these midpoints bisect each other, we need to prove. So here the diagram also not given, so construction is the main part here. If we draw the construction properly, so easily we can prove this type of question. Is it clear? Okay, now let's start here. So when we start this one, first of all, if you see the diagram here, the diagram is given like in this way. First of all, a quadrilateral, if you consider, and the quadrilateral is here we consider A, B, C, D. This one is a quadrilateral at first we consider. So as you see here written, let A, B, C, D is a quadrilateral, first point. And now in this quadrilateral, 4 midpoints are we consider. And in this side AB, the midpoint is P. Inside BC, the midpoint is Q. Inside CD, the midpoint is R. As well as inside AD, the midpoint is S. As you see here written. And then after that, what you have to do? We join this P, Q, Q, R, R, S, S, P. We join this 4 sides. Is it clear? Now here we draw one diagonal also. In this ABCD quadrilateral, we join this BD. You can join AC also, but here we need only one diagonal, so that's why we consider BD. If you consider AC, then also it is correct. Is it clear? Okay. Now after this construction part here, now what we need to prove? We need to prove the midpoints of the opposite sides of a quadrilateral bisect each other. That means if this ABCD is a quadrilateral, if we consider any 2 sides, suppose we consider AB and CD, these 2 are the opposite sides, as well as AD and BC are the opposite sides. So in this AB side, P is the midpoint, as well as in this CD, R is the midpoint. So if we join these 2, then we get a line here, PR, as well as the midpoint of AD, which one is S, the midpoint of BC, which one is Q. If we join these 2, then we get another line, which one is SQ. Our task is we need to prove here this PR and SQ bisect each other, we need to prove. Is it clear? We need to prove this PR and SQ bisect each other. So let's see how can we start this one. So first of all, if we consider the triangle ABD, this triangle first we consider. Which one? Listen carefully. ABD, this triangle we consider. If we consider this triangle here now, in this AD side S is the midpoint, in this AB side P is the midpoint. So if we join this SP, according to our midpoint theorem, we know if we join the midpoint, then this side, this line SP is always parallel to the third side. Third side means which one? BD. Isn't it? We consider the triangle ABD, and here S is the midpoint, P is the midpoint. If we join these two, then SP always parallel to BD according to our midpoint theorem. I hope all of you understood this one. And now here one more property we know. If SP is parallel to BD, then the length of SP is equal to half of BD. Isn't it? This one also we know. Understood? So we put this one is equation number 1. Now after that, again if we consider another triangle, and this time we consider the triangle BCD. Again the same property here. Q is the midpoint, R is the midpoint. So if we join QR, then obviously this QR is parallel to BD. Why? According to our midpoint theorem. So if QR is parallel to BD, then QR equals to what we write? QR equals to half of BD we can write. Understood? And then we put this one is equation number 2. Now if we compare this equation number 1 and equation number 2, SP parallel to BD as well as QR parallel to BD. So from here what we can say? SP parallel to QR. Isn't it? This side SP parallel to BD as well as QR is parallel to BD. From here what we can say? These two sides are also parallel. So that's why we write here SP parallel to QR. As well as already we prove in equation number 1, you see SP equal to half of BD, and as well as QR is also equal to half of BD. If we compare these two, then what we get? SP equal to QR also we get. Understood? Okay, now in this quadrilateral PQRS, if you see, or we can say SPQR, meaning is same. In this quadrilateral SPQR, SP parallel to QR we get, as well as SP is equal to QR we get. So one more property we know. If opposite sides are equal and parallel, so no doubt here SPQR is a quadrilateral, and in this quadrilateral SP is equal to QR and SP is equal to a parallel to QR. So one property we know, if in a quadrilateral opposite sides are equal and parallel, then it is what? Then it is a parallelogram. So obviously this SPQR is a parallelogram. And in this parallelogram, PR and SQ, these two are what? Diagonals. So one more property we know, diagonals of a parallelogram always bisect each other. So PR and SQ are the diagonals or not? From here what we can say? This SQ and PR bisect each other. All of you understood? So now here this SQ and PR bisect each other. That means what we need to prove? We need to prove this one, isn't it? So our main task is what? We need to prove first SPQR is a parallelogram, and if it is a parallelogram, then easily we can write SQ and PR bisect each other. Hence our proof is complete here. So finally what we have to write? Hence the line segment joining the midpoints of opposite sides of a quadrilateral bisect each other. Which one is our proof? I hope all of you understood this one. So in our next class, we complete this chapter. Only one question remains, question number 7. So in our next class, we complete this 7. Is it clear? Okay. Thank you.